times y derivative.
You're talking about this?
Yes.
Yes, so this will be rearranged as 2x squared y dy over dx. But I have to start from the beginning. So I have 1 over 2 the square root of x plus y plus 1 over 2 the square root of x plus y times dy over dx equals this 2xy squared plus, there are no two, we don't have two pluses, I'm just saying here, follow here, okay, so it's not done, and plus 2x squared y dy over dx. Obviously, these two terms that have the variable have to be on one side. This term that does not have the variable has to go to the other. So therefore, I don't know why they get separated like that. Sorry about that. So then, stop me if you have questions, please. So then, and when I move this term here, I will also directly factor out dy over dx because these are not like terms. So 1 over 2 the square root of x plus y minus 2x squared y times dy over dx must equal 2x squared to xy squared plus 1 over, of course it's minus, to the square root of x plus y. It's minus because I'm moving it to the other side. So let's do this one more time. So here I had 1 over 2 the square root of x plus y with dy over dx. I move this term, it becomes negative. So then I factor out dy over dx, and I have 1 over 2 the square root of x plus y minus 2x squared y. This term was already on the right-hand side, but this term was positive, does not have the variable, so it has to be moved to the other side. It was positive, it moves to the other side with a sign change. Final step, I need to solve for dy over dx. And this is the final step. How
You
do we
divide both sides?
Yes, exactly by the quantity that multiplies our variable. That's what we need to divide by, this in the denominator. 1 over 2 the square root of x plus y minus 2x squared y, and this is at the top, 2xy squared minus 1 over 2 the square root of x plus y. Yes, if you want to simplify multiplying top and bottom, I don't really prefer that method, but it works right now. You can multiply the top by this and the denominator by this. I never really use this method, but it works right now. So I have dy over dx equals 4x y squared, the square root of x plus y minus 1, and then 1 minus 2x squared y times 2 times the square root of x plus y. Or just leave it like this, or this is the final. Yes, a lot of work with these problems. I would like to choose one with finding an equation of the tangent line. Now, I know that you've seen find the equation of the tangent. Find the equation of the tangent. I know you're tired of it. I know. All the time we see find the equation of the tangent. Find the equation of the tangent. Why? One more time, let me explain why. So if this is a function, and this is a point, and this is the tangent, why is this so important to determine the equation of this tangent? Because later on in this chapter, we are going to use this line to approximate this function near this point, not here. Here I need another tangent to approximate over there. Not here. I need another tangent. It's too far away from this point. But if it's close, then if I use the function or the tangent to evaluate, I will not encounter a lot of error. So that's why this is so important. We call that the linearization of this function near A. So that's the reason why we all the time say, find the equation of the tangent, find the equation of the tangent. So you know why. Any questions so far? Do we feel better about implicit differentiation?
At least for me, not at all.
Which part is not clear?
I don't really understand anything that's going on. Just seems like a whole lot, and I'm getting overwhelmed by all the steps.
But you understand the differentiation part because everything was done so far till this point before 3.5. You understand the differentiation part, correct? This is nothing is new so far. What is new here is solving for dy over dx. But basically, at this point, this is a linear equation in dy over dx. So how do I solve an equation? I put terms with a variable on one side and terms without the variable on the other. And then I factor and divide. So is it something not clear about the differentiation process, or? Because all this part is nothing new. What I'm really teaching is how to use this notation in this section, how to use the notation, and how to solve a linear equation.
Is it
Yes?
when we're asking for the derivative of y
Yes?
that it's been? Is the derivative of y dy over dx?
Correct.
Is?
Yeah. Yeah. So it's the same thing. So all these are the same. Y prime,
So,
f prime, or dy over dx, all these three mean the same thing.
so you just have to differentiate the left side of the equation,
Both
and
sides.
then the right side of the equation,
Both sides.
and
We
put them equal to
differentiate,
each other.
and then you differentiate both sides, and you're looking for this variable to solve the equation for. So we differentiated both sides. We realized that the variable that we are looking for is in two terms. We factor dy from these two terms. We move this term to the other side and we divide it. To get this, I divide this by this. This is a linear equation now. 5x equals 10. So x is 10 over 5. 10 over 5. And the same thing here. This had an extra step because I needed to move this term next to the other term here. So I need to move this term next to this one and move this term next to this one. And once I did that, because I cannot combine those two, like they're not like terms, I cannot combine them. I put them together, I factor out dy over dx, and again, this is a linear equation. I'm solving for this. 5x equals 10. So x equals 10 over 5. Is that better?
Yeah, I think I'm starting to get
Yeah. So let's look at the third one, and I'm sure you'll feel even better. So let's look at x squared plus xy plus y squared equals 3. They want us, of course, to find the equation of the tangent line to the graph of whatever that is. It's an ellipse. But we don't need to know that. We don't need to do anything about that, I meant to say. So find the equation of the tangent at this point P. So I will be able to find the equation of the tangent with y minus y1 equals the slope times x minus x1, where this is 1 and this is 1, but I'm missing a very important part. How do I get this? So this is basically dy over dx when x is 1 and y is 1. So how do I proceed? Anyone would like to give it a try?
First, you would differentiate each side.
Yes, let's differentiate, keeping in mind this and this. These two are functions, not variables. So can anyone help now? It's okay if you're wrong.
Would it be 2x
Plus,
plus
remember now we reached the product. So I need to have two terms for the product.
1 plus then the
Careful, 1 times y though,
Oh, yeah.
plus x times, now I want the derivative of this.
dy over dx.
Yes, exactly. I reached the plus. How do I differentiate a function to the second power?
Would be
Would it be
2y times dy over dx.
Excellent, perfect, thank you very much. And the derivative, make sure we put the derivative on both sides. The derivative of 3 is
0.
absolutely, thank you very much. Remember our variable is this. These two terms are on one side, where they should be. These two have to go to the other. They are not like terms. What do we do? So I'm moving to the other side, negative 2x minus y. But these two are not.
Where did we get the second dy over dx?
A function to a power prime is n times f to n minus 1 times the function prime. 2, the function to 2 minus 1 times the function prime.
Oh, okay.
So,
Yes?
like, why didn't we use like dy over dx when it was just the y, like the second term y?
Here?
Yeah. Like, when exactly do we use it?
So let's do this again. So x squared prime is this. I have to differentiate as the product rule. Product rule. First function prime times the second function. I have to copy.
Oh, okay. I see it now.
Plus
Okay.
the first function times the second prime. Plus 2 times y to 2 minus 1 times the inner function prime. Is that better? Is it? Anyone?
It's me.
Good. So now I have these terms here, but they're not like terms. What do I do?
Sorry, could you go back a second? I think mine froze and someone else said theirs froze too. Just
Yeah, we lost
so
you
when-
for about 20 seconds.
So what should I do?
Back to explaining y squared. I think you were starting to do that.
Oh, okay. So y squared prime is 2 times y to 2 minus 1 times the inner function prime. Is that okay?
Yes.
Good. So now these two terms should be here. What do I need to do because they're not like terms?
factor out the x and the 2y.
Yes, but what I'm really doing, I'm factoring out dy over dx because that's common. So I have x plus 2y. So the common factor is this. This is what I factor out. Good. So then finally dy over dx, can anyone tell us what does that equal to?
Negative 2x minus y
Very
over
good. Yes.
plus 2.
Yes, same thing. Good. I prefer, since they're both negative, I put the negative in front. So now I want to evaluate this when x is 1 and y is 1. I'm swallowing stuff tonight. I'm not hungry. I'm not sure why. Okay, so negative 2 plus 1 is 3. 1 plus 2 is 3. Negative 1. So then I have finally the slope is negative 1. So y minus 1, negative x minus 1. So negative x plus 1 plus 1. So I get y equals negative x plus 2. This is the equation of the tangent line to the graph of the equation we had there. We were given to the graph at the point 1, comma 1. Do we feel a little bit better about this? Is that a yes? Is that a no?